Thank you very much. So yeah, welcome. I wanted to talk today about how we use Chef, how we embed Chef, and called a couple of differences between how OpsWorks is running Chef and how you're probably more used to using Chef Server, and also talk a little bit about the trade-offs that we made by doing so. Before we start, how many people know what OpsWorks is or have played with it a little bit? So have a little bit of experience? Okay. So for the others, just give me like a very, very short introduction so that you know what I'm talking about. So OpsWorks is an integrated application management service that helps you run complex applications on EC2. And we use Chef under the hood to do the actual provisioning of the software of, like, you say, I want to have a Rails application server or a Java application server. And for the actual installation of the software and the actual configuration of the instance, we use Chef. What is a little bit different about our setup, if you compare it to a traditional Chef world, is that if you used to be open source Chef or hosted Chef, you have like a Chef server and Chef client. In OpsWorks, we have our own backend that kind of mimics a Chef server. It's, and that's probably the majority of my talk today. Like, okay, what are the differences? But we use Chef client with zero. To do the actual run on the machine. We used to use Chef Solo until the last Chef update. So our backend kind of solves similar problems like Chef Server does, in addition of a couple of other things. And but the basic idea, once you're on an instance and you're running Chef, think of it as a normal Chef run, and the normal Chef Solo in the past. Nowadays, Chef client and zero, but the principle is pretty much the same. So if you look at our architecture. There are like two big important pieces. One is our backend, which which coordinates EC2 on your behalf, all the other sub-services like EBS or EIP or VPC and all of these other fancy acronyms that we have. But the basic idea is OpsWorks takes care for you for the integration with the Amazon world in terms of booting machines, configuring load balancers, doing auto scaling on your behalf, replacing dead machines, so doing all the interactions with the APIs that Amazon offers. On the other hand, we have our agent that bundles Chef. And that agent does the actual on-instance provisioning and configuration updates if anything should be necessary. Like I said, in the past we used Chef Solo, and with the recent update that we released a couple of weeks ago, we now use Chef Client and Chef Zero, which is an in-memory Chef server implementation that allows us to do a couple of integration of features that Chef Server has, like search, where in the past you had to do something a little bit different, which caused it like a friction. I would say if you come from open source Chef, you use the community cookbooks, you want to use OpsWorks, and that was always a little blocker, and we thankfully solved it by using Zero. But the general idea is OpsWorks is, for example, launching instances for you, like you're talking to the OpsWorks API or OpsWorks UI, and that triggers like a command, or we call it a lifecycle event, that we push down to the instance. And that command has the actual type of the event, plus it has some JSON that describes the command and describes the state of your universe. Like for that particular system, what other servers are there available, what is their state, what applications are deployed, and so on. Then we run Chef on the machine, like and bootstrap it, or do a deployment, or adapt the configuration. Depends on the actual command. And the agent is then pushing back the Chef log, the event status, the runtime information, and so on. And you can then in our UI view that and like see, oh, the deployment succeeded on 9 of my 10 application servers, but it failed on this particular machine, and you can dig into that and look into this. And I'm going to dig into a little bit deeper into that particular. How do we bundle Chef, and what are, if you have that kind of an infrastructure, what are the differences to like a normal Chef client that would like pull Chef server every 15 minutes? In general, we offer 3 different Chef versions that you can choose from: 09, 11.4, and 11.10. The general idea is we have a couple of our built-in cookbooks. They're all open source on GitHub if you like to like override them or change them, or you can bring your own. And the built-ins are just convenience. to help you get started faster, because for things like a Rails app or Node.js app or running PHP or MySQL or Memcached, we have like standard cookbooks that already take into account that they're running on OpsWorks and they can do some of the orchestration for you. The big difference is this lifecycle system. So whenever something happens, and I will talk about that in a second, we trigger like a chef run, push-based and not pull-based like you probably are used to if you use Chef Server. And each of those events, like I said, they bundle the stack state that we're going to look into in a couple of minutes, that give you the background information about your system that you can then evaluate, and that's available in Chef Search. And that gives you kind of the same functionality as you get from Chef Server. Not quite, but very comparable. Before we dig into that, I need to explain to you a little bit how you model things in OpsWorks. In OpsWorks, we have what we call stacks and layers, and those are our main modeling concepts. So a stack is a system, like you would have a stack for project X production, and then there's this different stack for the staging system and a different stack for a different project and so on. And in each stack, you have layers, which are groups of servers, like all my application servers, that's a layer, or my database servers, that's a layer. You can kind of think of them a little bit like chef roles. They actually predate, in that sense, chef roles. That's why they're not 100% the same thing. But in general, a layer is a place to store or define common functionality, common settings. Like you say, all my application servers, they should run those recipes when they start. They should run those recipes on deploy. They should have those packages installed. They should have an elastic IP or not. They should have an EBS volume attached that is of this size and that mount point. They should use those security groups. So you can kind of define what, or they should use this instance type by default. So you kind of have the settings that you want to use on AWS on EC2, like what instances are they, and what subnet are they, should they be in a VPC or not. All of those informations you can embed there, plus the actual chef runtime, and meaning the run list, basically. Like what kind of recipes do I want to run. And like I said, they're very similar to a chef role. But you don't have the full chef role functionality, but that's probably a very good analogy. We have a couple of built-in ones, like I said. They're not special in any kind. They're just like we instead of letting you start from zero, we provide, if you like, a couple of built-in types that you can use. You don't have to use them. You can bring your own. You can modify them. You can customize them. They're all open source on GitHub, but it's usually a very fast way to get you started, so that you don't look like a blank screen and like have, oh, how do I write my first chef recipe? But actually can deploy example Rails application, then pick it apart from there and override it and extend it. You can, of course, bring your own. So, I mean, you all guys probably know, I hope so, Chef. So, like in the end, you can bring your own cookbooks and define your own layers and just define their run list, basically. So we have customers running everything from Erlang to Cassandra clusters to like C applications, custom PHP installations, whatever you like, whatever you can run with Chef, we happily run it. We may not have like a default built-in cookbook for it, but of course you can bring your own. If you would like to do that, you can do that easily in our UI. So in this example, you would define a layer, you give it a name that how you would like to identify it in the UI, and then you give it a name which will identify it in Chef. So basically, that's the name of the role in Chef that you will find it. You can add the run list basically per lifecycle event, and I will talk about the lifecycle events in a minute. And then you can add instances and start them, and they will behave like you expect it to. So let's dig into the lifecycle events, and that's probably the biggest conceptual difference between OpsWorks and a normal Chef server setup. So in the normal Chef server setup, the clients usually pull every couple of minutes, every 15 minutes or something, from the server to see if there are any new cookbooks, any configuration updates, any changes that they need to run. In OpsWorks, the whole thing is a push model. That means if something interesting happens to your system, meaning usually you boot another machine, one of the machine crashes as being replaced by OpsWorks, you do auto-scaling and you add capacity, or you do an explicit deployment via the API UI, that is an event that will be propagated to your instances. This event basically will trigger a chef run, and then what happens in the chef run depends on your run list, like what you told us to do. So probably when you boot up a Rails application server, the first thing you want to do is like install Rails, install Apache, and all those things. That successful boot will trigger an event that then, for example, your load balancer can subscribe to and then adapt its configuration. So in the end, it's just breaking down like this one chef run that you usually have that does everything into smaller events or more fine-grained control over what you're actually interested in. You can, of course, just always run all your recipes and do like, and if you make sure that they're idempotent and just do the traditional chef way. If you like to, those event system gives you the ability to be more specific, and this means you're faster because you don't have to run all the recipes all the time, and it gives you more fine-grained control of what is actually happening. OpsWorks supports 5 different lifecycle events. Setup means like your instance is being provisioned for the first time. Then we have configure, which means something happened, like instances are coming or going. You probably want to check that your configuration is still up to date, like your load balancer is still pointing to all the application servers. The application servers are still using the right database server, and so on. Deploy is an explicit deployment. Then we have undeploy, which means you're like removing an application from the system, and then shutdown means I'm terminating an instance, and I have the ability to do like some cleanup jobs, like flush the file system or something like that. Now, when do we fire those events? Because we are very tightly coupled, of course, to EC2, like we fire them in different times on the lifetime of an EC2 instance. So if you have an EC2 instance, the state is what we consider like new, like you didn't launch it yet, you just defined it. Then you actually tell us to please start this instance on EC2 for me. So the instance will go through some state changes on EC2, like it's being requested, it's pending, it's booting, or running in EC2 terminology. And then as soon as the instance is actually alive, it will install the OpsWorks agent. The agent will connect back to our system and will request its initial configuration, which means it will run its setup. And setup being the first lifecycle event, which means it will run its initial provisioning. Once it succeeded doing this, we will fire a configuration event, which to the whole stack, which means all the other instances can now take advantage of this new node. Like your load balancer can reconfigure itself, your database server can add an ACL to allow this application server to connect, or whatever you like to do. Like basically we're telling you, hey, something changed in your system. You can respond to it if you like. The instance itself will now be called online, so it's available. It's reached like it's available state. If you like to, you can now of course deploy over its lifetime new versions of your application. And then at some point, you're going to shut down or terminate the instance, which will fire a configuration event because the state of your system changed. There are now fewer or less nodes than there were before. And the instance will actually shut down. At some point, it will complete the termination and will be again new or stopped or like not running on EC2. So just to briefly summarize the various events, that means the setup event, we fire that whenever you boot an instance and it's actually running, it will run its initial provisioning. It includes the deploy event, which means like you usually want to, if you boot up a new machine, at the end of the bootstrapping, you want it to be useful, so you probably want to deploy your application. What you usually do in that is you install the software that you actually need, like you install Apache, MySQL, whatever you actually need. Those recipes you would run here, meaning the initial installation. Then something special about the setup event that I want to briefly spend a minute on, because it surprises people sometimes. Because it includes the deploy event, the actual order of events will be first the OpsWorks setup recipes will run, then your setup recipes will run, then the OpsWorks deployment recipes will run, and then your own deployment recipes will run. That order is typical in that sense for all our events. So it's always like this: that first the OpsWorks run list will be run if there is any, and then your own run list will be run. Which means because setup includes deploy, there are actually 4 of them. Then the configure event is sent whenever there are instances entering or leaving the online state. It will be sent to all machines in your stack, and then usually you would not install a lot of software in it, but usually you would just like make sure your configuration is up to date. Means in Chef, like you would run or re-render any config files with template directories, providers, or anything like that. So the typical example is the load balancer regenerates its config file, like HA proxy regenerates its config file, checks that in this sense. It's load balancing the correct servers. MySQL, you would add an ACL for every available node, revoke ACLs from nodes that are no longer in this list, and so on. So those are the kind of recipes you would usually add to the configure event. Then we have the deployment event, which is triggered when you explicitly do a deploy of your software, either via the API or UI. You usually would use that to do any custom deployment actions or override our built-in deploys. The undeploy is usually something you use rarely. That is fine if you actually delete an application and you want to remove it from running machines. And then we have the shutdown event that we send to an individual instance when you terminate it, and you roughly have 45 seconds to do any last actions before you're being shut down. Usually you would use that if you have like MySQL and you terminate it, you probably want to make sure the server is terminating fine. So like you flush your disk, you write everything before you actually kill MySQL. If you do some kind of NoSQL database with gossip protocols, you maybe want to tell the other nodes that you're no longer available, or make sure you sync your state to them. So that is usually very useful. Or if you're running an application server, you gracefully terminate the application server, so it will like finish the request it's still processing, but not accept any new connections. What all of those events have in common is that they include the stack state. The stack state basically is a description of your system. It tells it is like a JSON state that will be available in Chef attributes under the OpsWorks namespace that tells you what kind of applications, what kind of layers are available, what instances are there, what are the IP addresses, their instance sizes, their EC2 availability zones, and all of that information. So you can find, for example, information about the instance you're actually running on under node OpsWorks instance, information about the stack, like what applications are being deployed, what is the name of the stack, the region, those kind of things under the stack namespace. And then there are the layers which tell you what layers are available, what instances are in there, and then information about the individual instances. And we will look in a second into that. But basically, all of that information is also available in search, and will be mapped to if you look up for roles in search. But that is the piece of information that in your recipes you can inspect and then decide if you need to do something, like you're interested only to do something on production stacks but not on development stacks. So you could encode that in the information that is in the stack namespace, or you could look at do I even have a MySQL layer? Like that would be you would find in the OpsWorks layers namespace. So how do we actually integrate with Chef, and how do you get all of that information? How do we what kind of Chef features do we support? Since a couple of weeks ago, we have native support in that sense for search, since we switched to using Chef 0 together with Chef Client. So all of the stack state information that I mentioned is available in search. So you can do like search node name web1 or name web star or whatever, like the usual search syntax that you use from Chef server. and you will find anything that is in this JSON state that we push down to the node. What you don't find, what is like a difference to Chef server, is anything that you dynamically generate on the node. So an example would be, or the reason is in Chef server, this information that the clients generate, it's being pushed back to the server and then indexed and available for future searches. In OpsWorks, we have like in that sense, for that kind of information, like a one-way direction for that. So everything that is available on the back end, you will find on the nodes, but anything that you generate in a recipe, in an attribute file, within the chef run is not being pushed back and indexed on the back end. So you will not be able to query like what packages are installed on a certain instance, for example. You will be able to query like anything the backend knows, like what all the instances that are available in a certain region or a certain availability zone on a certain instance type or of a certain hostname, whatever. All of that you will find in search, but you will not find anything that your cookbooks dynamically generate. Another example would be I can query for roles and then get back the private IPs and so on. So anything that you would imagine that is available for a typical node, like hostname, IP, DNS entries, the instance type, the AMI ID, the AZ. So basically anything that OHI will find out about the node, you will find in that search result. And like you see, what we do is we map roles into, or we map our layers into roles. So if you have an OpsWorks layer that is called PHP App Server, you will find it in search if you look for servers with the role PHP App Server. What we don't support yet is the ability to fully use the role definitions, because we currently only accept a cookbook repository or a cookbook directory that you give us, and not like the full-blown chef repository, meaning consisting of data bags and roles and environments and so on. This is something we're looking into. Ideally, we would like to be 100% compatible there. So that is our goal. But today, we're mapping all the layers into roles. So if you have a chef community cookbook that is looking up, like you have an HA proxy cookbook that says, I'm searching for all the servers that have the role PHP App Server, that will just work fine. As long as you're looking for or querying for roles. Similarly, we support data bags. So today we support them if you define them in custom JSON. Custom JSON is basically a free-form JSON field that you can define on stacks, and you can set anything that you set there will be available in the chef attribute. So it will, through the chef config file, will be pushed down to the chef run and will override basically anything that you have in an attribute file. This is one way to override anything that OpsWorks is doing. Another way that you can leverage is to define data bags. So in this example, anything that you define under OpsWorks data bags, and then in this example I have like 2 data bags with different items in it, will be then available in your chef run as a data bag. So to be a little bit more explicit, in this example I have a data bag called myapp that defines like username and password for MySQL, and then in a recipe you can access it like you used to from Chef. You can say databag item myapp MySQL, and then you get back the username and password and everything that you have in there. What we don't support today are encrypted data bags. The reason is we don't have a Chef server, right? So that doesn't mean that you cannot solve the same problem. So usually, the problem you're trying to solve with encrypted data bags is you have something that is secret, like the password to my payment provider, or my I don't know, Amazon access key or something like that, and you don't want to have it in your cookbooks because they're in GitHub, they're public, or all your interns have access to that, but you want to make sure that the production machines have access to it. There are two ways how you can solve it today. One I just showed you. You define the data bags in OpsWorks, which means it will not be in your cookbooks, but it will be available on all machines. The other way would be to basically create a JSON file, encrypt it, upload it to S3, and then you're giving your instances access to S3 via IAM instance profiles, which is a feature that IAM and EC2 has that allows you to give EC2 instances access to other AWS services without the necessity to put actually keys on them. Like they can actually, from the hypervisor on the metadata service, dynamically request a key that will be scoped to the permissions you gave this instance. So in this case, you could define that my instances are allowed to read from S3 from a particular location. And that's how you make sure that your instances get the secret, but nobody else can. And then in a recipe, you would access that information and then download, use the Ruby SDK, for example, in your recipe, and download from S3 the secret that you would like to transport to your machines. This is, of course, a little bit more complicated than just using encrypted data bags, but also gives you the ability to very fine-grade permissions with IAM. And you solve the same problem, which is how do I get a secret transported to my machine? Another thing that we have is support for Berkshire. So you can define which Berkshire version you want to use, and if you want to use it or not, of course. And what we will do before we will run Chef, we will run Berkshire to pull down all your external dependencies, and if you have a Berks file, and this way allow you to not have everything prepackaged in your own Cookbook repository. We support any version because what we will do is basically we will install before the chef run, we'll do gem install Berkshire if you don't have the correct version. Because that is pretty slow, because Berkshire has a lot of dependencies, we have precompiled versions for the latest releases in order to make it faster. But in general, like whenever there's or if there is a specific Berkshire version you want to use, you just have to tell us which one. And at the end, if it's not precompiled, we will install it from source. That means that you can have 3 different cookbooks that are being run. There are the built-in cookbooks. There are the side cookbooks, so like your custom cookbooks that you bring and you tell us to use from a Git URL or SVN repository, or like you put them somewhere in S3, for example. And then the Berkshire cookbooks that are being pulled down from your Berks file. So that means that, of course, you can use, because it's Berkshire, you have a Berks file, and in this example, we're using the APT and Bluepill and Arc and Built Essentials cookbooks, and we're pulling them down from GitHub, and anything that you know from Berkshire is supported in that sense. What is important to call out is that if we look at those 3 repositories or cookbook paths, is that we have the same behavior as Chef Solo here, where you can actually override templates and recipes and attributes files by that order. So the first place we're looking for something will be in our cookbook directory, then in the side cookbooks, and then the Berkshire cookbooks, and the last one wins in that sense. So if you're not happy with the built-in recipe that we have, you can actually override it by just putting it into your own cookbook repository, or by overriding it in a cookbook that you're pulling down with Berkshire. Same for attributes files or templates or anything. So this allows you to basically fully customize everything that we ship in our own cookbooks. Then another thing that you have in Chevron's are environments. Currently, we only support the standard or implicit default environment. Like I said, the reason is because we don't have, we don't accept yet the full Chef repository that has the environment directories and the role directories and so on. This is something that we're looking into. We want to support. But as long as you use the implicit environment, everything works fine. In that sense, one way how we imagine it to work, and that's something that where I would like, of course, to get your guys' feedback is, instead of just supplying your cookbook directory in as form as the customization, you would supply the whole Chef repository, and then we would just throw it on the machine available for Chef Solo and configure Chef Zero. Configure Chef Zero accordingly to look for role information there. Tag all the nodes like what we already do in search for being part of that role, so that they pick up the recipes for the run list and the attributes and so on, also from the role definition, and not only from what we sent down and what you defined in our UI or API for a particular machine. And this way, we would have the full support for roles and environments like you would expect from a normal Chef run. So, to summarize in that sense, what are the biggest differences between Chef Server and OpsWorks? One thing is to remember that there is not this one global run that you have in Chef, but in OpsWorks you have those discrete events that fire whenever something changes. And that means you can have more fine granular control if you like to. That also means that we have like a push model versus a pull model, which means the things that are a lot faster to respond. So usually people don't deploy via Chef run. They use maybe Knife, or maybe use an additional tool. But in OpsWorks, we can, because the events are push based, like it's not natural to deploy via Chef in that sense, because you explicitly generate an event, we push it onto the machines, they do the Chef run, which will pull the latest source of the application from GitHub and put it on the machine and restart your app server and so on. So we use Chef for everything because it's push-based and event-based. Something that is a little bit different is the node discovery. So we have search, like I said, for everything that is server-based or like information that we have in the backend. We also have this attribute tree, this stack state that I introduced. But what we're missing is actually access to dynamically generated data. And that would be also interesting to know if this is something that you guys actually need, or if it's something that is rarely used. Then encrypted data bags, we don't have built-in support for that. But there are the workarounds that I explained. Something that we would be able to support is actually something like Chef Vault, because that's not relying on the server storage. You can actually use like S3 or something like that for backends for that. And then environmental roles that I described. If you take this into account, and then it's pretty much a simple Chef environment that already has a lot of predefined cookbooks. Plus, then, of course, we take care of all the EC2 and AWS integration with things like VPC or ELB. So because we're totally integrated with them, we can reconfigure the Elastic load balancers for you. We can like replace that EC2 instance automatically and keep your configuration up to date. So the thing that you should remember in that sense about OpsWorks and where it differs is that we have this lifecycle framework. It's highly customizable, so you can basically override anything that we ship in terms of the cookbooks and the recipes. They're just convenient. You don't have to use them. And then we will try to integrate more and more over time with the with Chef and of course with other AWS services, so that our goal is for you to be able to take any community cookbook, and it will just work on OpsWorks because the environment will be the same. Maybe under the hood, the thing will work a little bit differently, but to the cookbook, the APIs will be the same. The behavior will be hopefully identical. Today, like I said, it's in a couple of places, like encrypted data bags or search. It's a little bit different, but hopefully not very long. If you want to know and learn more about OpsWorks and how to leverage it, there's of course documentation. There is a blog that AWS manages about application management tools, and there are also a lot of videos on YouTube on how to get started in OpsWorks and how to run community cookbooks like the MongoDB cookbook or use Berkshire and so on. So that would be everything that I have, and I would be very interested to get feedback from you guys, like if you have some OpsWorks experiences, what are things that we could do better and where the integration with the normal Chef ecosystem could be better. Yes, please.
Within the last week, I've noticed that spinning up new instances, it instead of using the precompiled work shell, it's trying to actually go and download its own and compile. And then the second problem with that is, even though it's trying to do that, it's failing the dependency for G code. Is that a known issue, or?
I think this is a known issue, and I'm not sure if it's already fixed or should be fixed very soon, but...
Yeah, I tried this morning. It's still didn't work.
Okay, so then it's not fixed. But then, yeah, we know about that, and that is currently being addressed. I think the reason is that this dependency was recently introduced, and the precompiled versions didn't have it. But it should be then precompiled very soon, so that the instance bootstrap is very quick again.
And with the release of 301 for Berkshire, are you guys going to update the precompiled as well?
Yeah. So we will have a precompiled version for 301. Any other questions, comments, feedback? Yes, please.
Say a little bit about how you integrate with the cloud formation ecosystem.
Yeah. So that's a good point. So the question was, how do we integrate with CloudFormation? And before I answer that, maybe let me spend one sentence about because we get this question a lot. What should I use? Should I use Beanstalk, OpsWorks, or CloudFormation, and how do they relate to each other? So the answer to that is that they're all three different tools that solve a little bit different problems and appeal to different types of people depending what problem you want to solve. So the easiest thing to imagine is if you look at the continuum from you have a lot of convenience but not a lot of control because you're running in a sandbox, which is gives you a very easy start, but probably at some point when your application gets too complicated and has a lot of dependencies and you want to customize a lot, you're like hitting the limitations of a sandbox on one end of the spectrum, and then on the other end of the spectrum you have like raw EC2 and you have to do everything yourself and manually. Then you could say Beanstalk is probably over here, OpsWorks is somewhere in the middle, and CloudFormation is a little bit more to the right, and then you have, of course, pure EC2. And depending on how much control you want to have, how much convenience, and how much of a easy start to get started, depending where you are, like the different solutions have different benefits to you or appeal differently. You can, with CloudFormation, you can actually automate OpsWorks and Beanstalk in that sense, so that you can have a CloudFormation template that creates an OpsWorks stack for you that defines applications and instances and so on. So you can use CloudFormation to drive OpsWorks if you like. That was launched recently with CloudFormation. We will also, over time, make sure that all the OpsWorks features are available in the CloudFormation template, like deployment, for example. Other questions? Yes, please.
Is like the role information, if you do a search, is that global to all of like your OpsWorks stacks, or is it within?
So all of those, so this is local per stack. So everything that you find in the stack state or in search is local to a stack. So if you have like my CMS system staging, you of course will not find if you do a search the production servers. There are cases where you're actually interested in that. Like let's say I have a global application that is running in multiple regions, and I'm interested in order to do data replication in information about other nodes. What you would use there is you can use the public API to query that. So you would use IAM instance roles or instance profiles to grant your servers permission to query the OpsWorks API, like to do a describe stacks or describe instances in that other region. So then you would in your recipe use the AWS Ruby SDK, query the API, get that information. You don't have to do that. You can of course do that for the same stack in that sense, but the easier way to do is search and the OpsWorks stacked JSON. Yes, please.
I'm just curious, is there any thoughts, like, that sounds a little bit convoluted versus potentially just using something like tag, I guess, directly? Is that something that you do or not?
You mean EC2 tags or what? So OpsWorks tags all the instances and volumes and so on that we use on EC2. So you can actually, if you open the EC2 console, you will see them nicely tagged by stack and instance name and so on. We're also looking into supporting the tags in search if this is what you're looking into. Yeah.
That's, I guess, what I would say.
Yeah.
That seems a lot nicer.
Yeah. So that's something that we're looking into, and it's interesting to see that you guys are think it's a good idea. Cool. Yeah, so thank you very much. If you have any questions, I will be here all day. And have fun at the rest of the conference.